graphing using slope, y-intercept, and x-intercept. So we're going to do like two different methods. They just kind of use the same words. So we've already gone through this question. We'll kind of show it over here. We went through it. We found the point of intersection by using elimination is -8 and 3. So in this one, what we're going to do is we're going to graph these and see if our graph kind of matches that idea. So we're going to use the intercept method for the first one. And the reason being, I'll rewrite the first formula, -2x plus 4y equals 28. The reason that'll be easiest is because to find the x-intercept, you set y equal to 0. And to find the y-intercept, you set x equal to 0. And since these are kind of already set up this-ish way, it's simpler. When we set one of them equal to 0, it'll eliminate that whole term and we'll be set with the other, and vice versa. Okay, so let's do that first. So let's find our x-intercept first. We're going to set y equal to 0. So we get -2x plus 4 times y, and y is 0, equals 28. Okay, so -2, and 4 times 0 is nothing, so -2x is equal to 28. So I'll just rewrite it a little closer. 2x equals 28. To get x by itself, we take 28 and divide by -2, and we get x equals -14 as an intercept. So this intercept is at -14 and 0. So that's just a point on the line, not like a point of intersection or anything else like that. Let's do the same idea, same equation, but this time -2, and we set x equal to 0. So this will find the y-intercept, plus 4y equals 28. This cancels out, so we get 4y equals 28. Y equals 28 divided 4. Y is 7. So this intercept is 0, 7. So these are the two coordinates for that. And what I'll do is just quickly bring out a graph. Maybe I'll just graph. -14, 0 is one of our coordinates. Okay, so -14 and 0. Whoops, that's not right. -14 and 0. That would be here. -14 and 0. And the other coordinate is 0, 7. So 0 and 7 would be kind of in between there. Okay. So what we're doing is connecting our two dots here, and we could extend them. There we go. Maybe our line kind of goes like roughly like that, and same the other way. So here's our first line. The other method we're going to use for our other equation is slope y-intercept, and the reason we're going to use that one is because this is already set up for the slope. That's y equals mx plus b. This is our m. This is our b. That's a 9. I know it looks like a d or an a. I don't know what it is. But that's the -9. So the y-intercept is -9, and the slope is -3/2. So our rise is down 3, and our run is to the right 2. Or the opposite, up 3 to the left 2. We'll do the exact same thing. So let's go to -9. Our y-intercept is at -9. So that's 10. This is 9. Okay, so a little harder to count on this one. But we said the rise was down 3, so that's 1, 2, 3, and over 2. So that's 1, 2. And it doesn't look like I counted that in units, but you got to take a look at what our scale was, right? Our scale was by 2, so a half movement is 1. So a half movement is 1. So here's our first one. And we said we could do the opposite. We can go up 1, 2, 3, and to the left 1, 2. And we are on the exact same line. So we'll try to graph this line here in blue. Okay, so it kind of goes like that, and we'll extend it to see how far it goes. So they have a point of intersection, okay, and it's very hard to see what that is. And that's the problem sometimes when graphing for points of intersection. We're kind of estimating what that value is. Now, like we said, we found in our other question we were at -8 and 3. So when we go take a look at our graph, -8 and 3 is about there. So I've just misdrawn the line a little, but that makes sense. That is roughly about what we've seen in this question. So in terms of graphing, let's go whole page. That works out pretty good using those two styles. Whoops. There we go. Okay. So I just quickly graphed these here. The red line is exactly what we've shown, and the blue line is pretty much what we'd shown, and they intersect at -3 and 8. Now these coordinates, this is the only coordinate that runs through both of the same two lines. So when we check algebraically, it fulfills both. Both the left side and the right side will be equal. If you were to plug -14, 0 into the equation of the blue line, you would get two sides that aren't equal because it doesn't fall on the blue line. And vice versa, 0, 9, if you plug that coordinate into the red line, you would get two sides that aren't equal either because it's not on the red line. This is the only coordinate that suffices that no matter which of the equations you plug it into, the left side will equal the right side in that case.